Well, let us look at item 3. Item 3, we go through it all together. The government of Uganda plans to set up a nuclear reactor to reduce the energy cost in the country. The following ideas were fronted by one of the members of parliament. All the workers at the plant were to wear safety wear to a detailed procedure on how radioactive materials produce electricity was to be presented, and 3, assuming 1 kilogram of radioactive material with half-life of 2 weeks is to be used. A clear time frame is required as to when a replacement will be required. A hint down here, the radioactive material will only be used to produce electricity when the mass of a material is more than 50 kilograms. Use your knowledge of physics to help provide a suitable response to the member of parliament about the raised concerns. Before we try to answer this question, let us go back, as the item requires us to provide a suitable response to the member of parliament about the raised concerns. Let us go back to our question and identify what are these concerns that the member of parliament requested. The first one that was all the members, all the workers at the plant were to wear safety wear. Now remember, we had a nuclear reactor. Now, before we try to dig deep into this concern, let us first look at what is a nuclear reactor and what is really done in the nuclear reactor. This is going to enable us find out why are really these workers requested to wear safety wear when they are at the what? At the plant. Now, a nuclear reactor is the heart of a nuclear power plant. These nuclear reactors contain and control nuclear chain reactions that produce heat through a physical process called the nuclear fission. That heat is used to make steam that spins a turbine to create electricity. So a nuclear reactor is the heart of a nuclear power plant, meaning that a nuclear power plant cannot exist without nuclear reactors. They use nuclear reactions, and that nuclear reaction used there is what we call the nuclear fission. When inside the nuclear power plant, there are a number of radiations that are emitted by the nuclear reactor. Now, these radiations are very, very, very dangerous to human life. So, as a person who really needs your life, you must save your life by wearing safety wear. Before me, I have two people. I have a person A and person B. We assume that these two people are beekeepers. This is a beekeeper A and a beekeeper B. If they have gone to harvest their honey in a beehive and bees become violent, which of these two people do you think is going to find a lot of challenges? We have person A and person B. To your own understanding, you are going to see that person B is going to find a lot of challenges. One, the face is not covered, even his hands are not what? Covered. So you expect the bees to beat this person seriously and to cause her harm, whereas person A will be safe. Why? Look at him. He is covered everywhere. Everywhere is covered. Now, we assume this is now a nuclear plant inside here. This is a nuclear plant with the radiations. And also this is another nuclear plant with also what? With the radiations. Now we say these radiations are very dangerous to human life because they cause skin irritations. So once you are not covered, these radiations are going to react with your skin and you're going to find a problem with your skin with irritations. Two, because you are inhaling these radiations, you're going to find that your body immunity is going to lower. And three, you're going to find that even they cause cancer. They can cause cancer. So these radiations in this room are very dangerous because of the above problems they cause to our bodies. As a result, you are required to put on safety wear as you are dealing with radioactive materials. Secondly, you also need to store radioactive materials in a nuclear plant. In what? In lead containers. Why? Because these radioactive materials do not penetrate through lead containers. So that is how you can also safeguard yourselves. 3, you can also hold the radioactive materials with what? Pair of, now this should be computerized tongs. So that is how you can safeguard yourself against the danger of radioactive materials. So that was our first concern. So our second concern was a detailed procedure of how radioactive materials produce electricity was to be presented. Okay, remember we are looking at a nuclear reactor. We said a nuclear reactor uses what we call nuclear fission. So we are going to explain what nuclear fission is. Now, before we try to go deep, let us first have a look at this. With me, I have a nucleus, like you have seen it. It's a heavy one. As I bombard it, what I'm bombarding is a neutron. So I have a nucleus. You can say that nucleus is uranium 92 235. Now I'm going to bombard this uranium. You see, I'm actually bombarding it. What am I bombarding it with? It's a neutron. That is a neutron. Now, as a result of that bombarding, that reaction, this uranium becomes unstable. Because it has been stable, you know, when you hit something, like an egg, you can hit it with a spoon, it becomes what? Unstable. So once it becomes unstable, you expect that egg, I expect this uranium to break into further nuclei. Yes, that is what has happened. It was one previously, then bombarded with a nucleus, so with a neutron, and finally it becomes unstable, then splits into two lighter nuclei. Have nuclei A and nuclei B. So you can say the first nuclei A can be, now you can say it may form barium, that is 56 and 141, plus can say another nucleus B can be krypton 36 92. But remember, even the neutron that hit that uranium did not go anywhere. Of course, it will come out as a result. It will also split inside there because that reaction was so vigorous. So I expect some neutrons to also be as part of the results. Now what we are seeing this beyond, this is now energy. That is energy. So plus energy. Now when we try to balance this equation, we have 92 as the mass number. Then this side we have 56 plus 36, we have 92 also this side. 92 is equal to 92. Then try to balance our this is atomic mass. So atomic number 92 are equal. Then we have mass number 235 plus 1, that is 236. Then try to add this side. We have 230. Actually, I have 230 what? 33. So we must make sure that our mass numbers balance. So you can add the 3 here. So I have 3 neutrons plus 3 such that our equation now balances 230 what? 36 on both sides. Now, this is a nuclear fission. We can conclude by saying a nuclear fission is simply a reaction where a heavy stable nucleus splits so is a nuclear reaction where a heavy unstable nucleus splits into two stable nucleus, so a nuclei with release of energy, Now, which energy is released here? This energy is heat energy. Now, once this heat is produced in a nuclear reactor, this heat is used to heat what? To heat water at a very high temperature. Now once this water is heated, it produces steam at a very high pressure. Now it is this that drives the turbines, which are connected to generators that convert mechanical energy into what? Into electrical what? Into electrical energy. Once we have electrical energy, it means now we can now see that we have produced what? Electricity. Okay, so that is how the second concern was. That was a report on how electricity was to be what? Produced. Concern number 3. Remember, I have to go through all the concerns. Concern number 3 required us assuming 1 kilogram of radioactive material with half life of 2 weeks. Before we answer this, let us first understand what is half-life. Half-life, simply, this is the time taken for a radioactive material to decay to half of its original mass. To half of its original mass. Now we assume that this was 1 kilogram. It was 1 kilogram. 1 kilogram is 1,000 what? 1,000 grams. It will take 2 weeks to decay to half. The half of this 1,000 is 500 what? 500 grams. But remember, our question says the hint says the radioactive material will only be used to produce electricity when the mass of the material is more than what? 50 grams. So we must make sure that we decay the 1,000 grams to a mass that is more than 50 what? 50 grams. Okay, let us proceed. From 500 grams, we shall have a half of 500 grams for another 2 weeks to be 200 what? 50 grams. So another 2 weeks, the half of 250 will be 125. So that is 2 weeks. So hope we are adding 2 weeks plus 2 weeks, that is 4 weeks, plus another 2 weeks, 6 weeks, plus still a half of 125 grams for another 2 weeks, that is 62.5 grams. Hope you're pressing your calculators. You are getting half of this, half of that, half of this, still half of that, and half of this. So these are 2 weeks plus 2 weeks, that is 4. 4 plus 2, 6. 6 plus another 2, that is what? That is 80 weeks. But remember, we must have a mass. We must decay this to a mass that is more than 50 what? 50 grams. So we can have another half of 62.5. That is try to press my calculator here. It is giving me 31.225 what? Grams. That is for another 2 weeks. So we have exceeded. Our limit was to have a mass that is greater than what? Greater than 50 what? 50 grams. And after 10 weeks, of course you've added from 1000 to 31.25. We have there 10 what? We have a total of 10 weeks. A total of 10. So remember, we have been given a time frame. Which time frame is required as to when replacement will be what? Will be required. And a hint here was that mass of the radioactive material should be more than 50 what? 50 grams. And after 10 weeks, the radioactive material is 31.25 what? Grams. So we can now conclude by saying the replacement will be done after a time frame of what? Of 10 weeks. So item 3, you are meant to identify that these radioactive materials are what? Are dangerous. So you earn the mark of identifying that they are dangerous. So earn that mark of identification. Like our guide here, we have I. This I stands in for identifying the problem. So I've identified our problem was the radioactive materials are dangerous. So this R here stands in for reasoning. After saying that yes, they are dangerous, now how do you reason out to a person that they are dangerous? 1, they cause any skin what? Irritation. So that is your reasoning. You are now giving the dangers of radioactive materials. 2, they can cause headache. So that is another reasoning. Lower body what? Immunity. That is another reasoning. R, cancer. Next. Okay. So these are the expected dangers of radioactive materials. The safety ways were such as wearing lead jackets. So now here we are identifying our safety ways. So and this mark of identifying the safety ways are now lead jackets, wearing lead jackets, wearing jackets, also that is another reasoning mark. Holding radioactive materials with computerized tongs to ensure they reduce exposure to what? To them, which exposes what? Exposes them. Also under this mark of using computerized what? Tongs. So sum up these points, a person who gave between 4 to 14 points, you earn 6 marks. Between 4 to 8 points, you earn 3 marks. Between 6 to 3 points, you earn 0 what? 0 mark. Okay. So when we look at part B, you are meant to give a detailed report on how radioactive materials produce what? Electricity. Okay, we said earlier that it is what? It's a uranium that is bombarded with what? With the neutrons. So you are meant to identify that yes, In a nuclear reactor, we use what we call the uranium that is bombarded with electrons. So you earn this mark for identifying that. Then according to the equation below, so you'd earn this mark of writing that equation. Okay. So now come down to our reasoning. The energy produced is heat Is heat energy. This energy we see here, so that is heat Heat energy, which is used to heat To heat water. The water produces steam at a high temperature, also under that mark. It is used to run To run turbines, which are connected to generators that convert mechanical energy to electrical energy. Okay. And lastly, our part C, we are to decay 1000 grams of radioactive material to a value that is greater than 50 grams. So we began with our mass of 1000, half-life, half of 1000, it is 5000. So that one takes 2 weeks. From 500 we move to 250 grams for other 2 weeks, so that is 4 weeks. From 250 to 125 for other 2 weeks, that is 6 weeks. And lastly, from 125 to 62.5 for other 2 weeks, that is 8 weeks. And finally, from 62.5, half of it is 31.25, that is other 2 weeks, to make 10 weeks. So you can now come down and conclude. We concluded by after 10 weeks, the mass present is 31.25. Therefore, the material replacement would be required after 10 weeks.